A standing wave is a wave that is created so that it looks like it's actually standing still. Now, in order to create a standing wave, you need two fixed ends. So this can be done with a piece of string or a spring or a lot of different materials where you could actually just take this material and just shake it up and down such that you have one end fixed and the other end fixed as well once everything's all said and done. So if we have a fixed end here, and if we have a fixed end over here, basically what's going to happen to create a standing wave is you're going to send a wave down this string. Let's just say it's a piece of string. You send the wave down the string, it's going to reflect back, and as we've seen with wave reflection, when it gets reflected back, it's actually going to move to the other side of the medium. So since it moves to the other side of the medium, it's actually going to create almost like a full loop. In fact, the very basic standing wave we can create is if you send one single wave pulse and it gets propagated back on the other side, you will see one full loop. So it's important to understand that this is one loop. And it's also important to understand that we have the fixed end on both sides. And these fixed ends that we have look like they're going to be standing still. It does not look like it's going to be moving. In fact, if you look at the entire loop, it's going to look as if this loop is just sitting there and nothing's actually happening with that loop. So these here are called nodes. And then the exact middle, where the amplitude is the greatest, so this is the amplitude, and this is the amplitude on the other side, we have here the antinode. So we have an antinode here where we have our amplitude. So amplitude from the center to the top, center to the bottom, that's going to be our greatest amplitude, that's going to be our antinode. So this is where you have one loop. Now it's important to understand what one loop actually is. And if you think about it in terms of wave terminology, if you're going from where it's moving up to the crest down to the medium again, this is actually half of a wavelength. So one loop is exactly equal to one half of a wavelength. Now, you don't have to create a standing wave with just one loop. You can actually create a standing wave where you have two loops. So if we look at the next possible standing wave that we could have a standing wave that's created like this, where it looks like there's two loops. So if there's two loops here, this is actually one full wavelength. And we have a node, we have a node, and we have a node. So there's three nodes here. And then we have our antinodes. So two antinodes. And then if you wanted to keep going, you could create another one. So for the next one, you'd have three loops. So we'd have to have four nodes. So we'd have something that looks like this. And this would be our next standing wave. So this would be three loops. And this would be 1 1/2 wavelength. Because we'd have one full wave and another half a wave. So 1 1/2 full wavelengths. So we have 1, 2, 3, 4 nodes and 3 antinodes for this one. So you can probably develop a pattern here. If you look here, we have two nodes. We have one antinode. Over here we have three nodes. And we have two antinodes. Over here we have four nodes, and we have three antinodes. So again, I'm not going to go ahead and show you the full pattern or come up with an equation. I think that's something you can do on your own. But you can see there is a pattern that actually is developed here. Now it's important to understand that this is going to be our first harmonic, also known as our fundamental frequency. This is going to be our second harmonic. And this one's going to be our third harmonic. And if we look at overtones, we're going to have here our fundamental frequency. So this is going to be the first overtone. And this is going to be the second overtone. So this is what occurs when you have your standing waves on a string.